Hi, this is TomReardon, math teacher from Ohio. We're talking about inserting pictures and using mathematics to model the shapes on those pictures. TINspire CX, the handheld and the software are now in very nice color. Why TINspire CX? It is a learning tool and a teaching tool. It is no longer just a graphing calculator with a touchpad and in beautiful color. Picture is worth 1,000 words. I say it is worth several equations. With TINspire CX, students can investigate how to model mathematically shapes that occur in the real world for themselves. Watch. We will be using TINspire SmartView emulator software, but whatever we do will look exactly like this on the student's handheld. First one is going to show you a picture and ask the students by guess and check to come up with an equation that models this fountain right here. Trying to find an equation that will go through those points of that, and we're doing it by guess and check, and ask the student to keep track of that. So one possibility, a student might say, well, that's negative x squared. It's opening downwards. So I'll go ahead and graph that. And not too shabby, but we've got a ways to go. So the student could move this and then edit this here. So I'm going to say, it looks like we need to move the curve up maybe about 4. And that looks like maybe not enough, maybe 4.5. And that's a little better. We need to move it to the left. So to do that, we do need to have something in parentheses here. The quantity of x, since it's going to the left, we need a plus sign, about 2. So that should move it to the left, about 2. And that looks like it's a little bit too much. So let's maybe back off on that 2 and maybe make it a 1.8. Okay. It's too narrow. So in order to do that, we need to change this maybe to negative 0.5. And that's better, but it needs to be wider. So the student's going to have to know to make that number smaller in absolute value. And negative 0.4 really wasn't the best. How about 3.5? And I'm going to be happy with that. I'm going to go ahead and right click on this and make the attribute so it is a little bit thicker, so it shows up better. So there's my guess, and not too bad, but look at all the mathematics that was learned or used here. This moves the graph up, the 4.5, the 1.8, the plus 1.8 shifts it to the left, and then negative 0.35 makes it upside down and wider. This is something that all students are doing at their own pace, individually. This is great mathematics here. An alternative way to do this would be to have the students use features of TINspire to come up with the equation. We know it's of the form y equals negative x squared. A student could grab, let's say, the vertex and move it where it's supposed to be, about where the vertex would be, and then widen out the curve so that it goes through there. And widen that a little bit more. There we go. And you can see that the equation that we have here and the equation that we had on the previous one, we're not too far off, and it's pretty decent. So to recap, on the left side was one that I did by guess and check. On the right side is one where we kind of just let the calculator do its work. I think things can be learned from both, but I definitely like the one on the left better. In fact, I'm just as happy with my equation as the calculator's equation. So, and students would argue that too. This is the